Hello and welcome to GitLab Migration feature overview. This is a GitLab feature that allows you to migrate groups from one instance of GitLab to another. And these two URLs where you can find more information about them. But basically, the first thing I'm going to do is show you a demo of what it does. So if you go to new group and then you click import group, you will be presented with this form where you fill out the source URL and the access token, click connect, and this will be the page that you're going to be presented with, which lists top level groups on your instance. Once you select the group you want to import and you select the destination. So for example, this is the source group that I have. It's opened for me right here. So we have two subgroups here, two projects, and then in every of the subgroups we have two more projects in each. Okay, and then you select the destination group on destination instance of GitLab and click import, but I already did that. It presents me with the option to re-import it under a new destination, but here you can see last imported to grade group. And if we compare the two, we're going to see that the grade group also has two subgroups and 6 projects in total. There. Cool. So why do we work on this to begin with? Some people may know that we have existing import-export solution, which allows you to do exactly, well, more or less exactly the same thing, although it does require a bit more steps to achieve the same result. So import-export solution that we have allows users to do the same thing, but it's only one group and one project at a time. And the primary reason that the end user has to deal with multiple files. You can export a project or a group and download the tarball file, and then on the destination you have to manually select that file and upload it. So if you have a lot of groups, if let's say you have a large organization and you have to migrate over a complex group structure, you know, with a number of subgroups that span deeply into the tree. Let's say you have, I don't know, 10 subgroups, 10 levels, 10 nested levels for the group, and then in each of the levels you have the amount of projects. You can imagine that's a quite tedious and time-consuming process. So the idea here is to improve the user experience and allow you to migrate all of your groups and all of your projects within one or a few clicks. Technically not one, more than one, but still a way simpler process than before. The other reason is import-export is a single process that can take quite a long time, especially if you have groups or projects that are of significant size. You know, it can take hours, sometimes tens of hours to import or export a certain project. So the new approach is a bit more distributed across multiple sidekick jobs, which should help with performance and not occupy a single process for too long. So now I'm going to go through a technical overview for this feature. The product name is GitLab Migration, but in the code, everything is named bulk import. So we have the bulk import main model that stores the overall state of import process. And I did a little drawing, and I apologize in advance for how it looks, but here it is, and I'm gonna move around to show you a bit more. But right now, you can think of bulk import as an entity that has that keeps track of state for the overall import. So for example, here, when we have this structure, which is not, it's fairly simple, but at the same time, it has a little bit of complexity. In order for us to present complete status, this is the status that oversees the entire import process. And I have a database viewer here, and everything that is prefixed with bulk import is belongs to this code base. So I have bulk imports table here, and the example that I showed before, we have a status 2, which is finished. And bulk import has a few associations. It has a configuration, which is essentially a the URL and the access token. The page that I showed you before, where you import your group, when you enter this information, this is where it gets stored in order for the background processing to retrieve the data, and to use that information to connect to the source instance. And yeah, if we take a look at the table structure, yeah, it has the source type. Don't have to worry about it too much at the moment. It's always set to GitLab at the moment, but ideally the grand vision for this code base is to be able to migrate all of the importers into one way of importing. For instance, GitHub, Bitbucket, etc. But yeah, the most important thing is status. Now, and the second thing that bulk import has is entities. So entities represent one of two things, either a group or a project. Here's a little snippet that kind of helps visualize what I'm talking about here. You can think of it, let's say you have a root group, and it has a subgroup which has a project, and the root group has a project as well. Then in that case, we're going to create this kind of structure that we will have an entity that is of source type group entity, and it will have preserved associations where, let's say, this group entity will have a parent ID of this group entity, and this will allow us to recreate this kind of structure on destination. So yeah, the bulk import entity is a representation of either a group or a project. So for instance, here we have the source type, which is a group, either a group entity or a project entity. And in our drawing here, again, yeah, I apologize for this ugliness, but I hope it does get the point across that for every bulk import, the overarching import, we have a number of entities that we create in the database, and each of the entities represent either a group or a project, and they all have also status of that we need to keep track of. So it's like a tree, right? So we have the import that has its own status, then individual entities has their own status as well. So we have, let's say in this case, we have a root group, a subgroup, and a project, just like I said, root group, subgroup, and project. And yeah, you have the source type and the name, space ID, the project ID, etc. And we can have a look at the project entities table. Yeah, that's the representation. But if you take a look at the contents, you can map out you can recreate the same structure on destination. So for instance, we have this record here, and the source full path, we need to store the source full path, the destination name, destination namespace. And then if it's a group entity, then it's going to have an associated namespace ID. If it's a project entity, it's going to have an associated project ID. And obviously the source type will change. So that's how we keep track of individual groups and projects imports. And for bulk import, we have bulk import worker. This is the main entry point for bulk imports. This is where we create entities. This is where we enqueue the workers. So each entity is going to have their own worker to perform. But in fact, this is not where the actual import is happening. If we take a look at the entity worker, what we do here is we do some administrative work, and then we enqueue yet another worker that is called pipeline worker. And that's something that is what we're going to cover next. So just one more time. So the bulk import so far stores the state for the overall import process. The configuration stores credentials. The entity stores the information about group or project to import, and the import state as well, to keep track of what's finished, what's still in progress. Now, the next thing that we create for after entity is pipeline trackers. So for every entity, we have a number of trackers that we are going to create. And trackers are essentially database records that also have state, that are records to keep state of import for small things like labels import or milestones import or epics import. So if we have a look at the imports entity, bulk imports entity, it has many trackers and it has many failures and it has a state. You know, the model itself is quite small. But if we open the tracker, in the tracker we store the relation name. So for example, labels, milestones, epics, whatever, and the pipeline name. If we have a look at the trackers table, it has a lot of information, but let's say we focus on this first one for now. You know, it's a badges pipeline, which indicates that we are importing badges for this particular pipeline, right? The job ID, the stage, I'll cover stage in a bit, and the status too, which is finished. So you can kind of map out to yourself. So here's the trackers, and they all actually perform via the pipeline worker. And the pipeline worker is the one that actually is performing the import. Okay, so we have like this tree of asynchronous workers. First, we create an import record and queue entity workers. Entity workers create trackers. And then trackers actually execute these small pipelines asynchronously, I mean, this in a distributed fashion, so that it's not all performed within one single process. And these workers perform pipelines, and I haven't touched on what pipelines are yet, but I will in a second. And when these workers, the pipeline worker executes, and if something goes wrong, at any point of import, we also create a bulk imports failure record. So for example, here we have group avatar pipeline error 404. Yeah, bulk import error. Just something to help us with debugging. So, like I said, the pipeline tracker is the one that is executing the pipeline. This tracker is the pipeline tracker, right? But what is a pipeline? And the pipeline, okay, I haven't mentioned what this is yet, but I will in the future. The pipeline is the ETL pipeline, which stands for extract, transform, load. It's quite a common method to use in data processing, where you have something like this. You have separate parts, separate pieces of responsibility that are responsible for smaller things, right? So we have a separate extractor that goes ahead and fetches the data. Then we have the transform layer, where we transform the data to fit our needs, normalize it or clean it or whatever. And then we load it. In our case, all of the use cases for the load is just persisting the database, but you can think of the load being anything you want, like let's say writing to file is another valid loading step. So how would a pipeline look like? Well, let's say we have a labels pipeline, or let's start with members pipeline. We have a custom DSL built for bulk import pipelines, and you can see it in this module here, bulk imports pipeline. It allows you to define extractor, transformers, and loaders. You don't have to use the DSL if you don't want to. You can just use, method definition. Made a typo here. But anyway, some pipelines don't use the full DSL, some do. Here's how an example pipeline can look like. So this is the groups pipeline that is responsible for importing group members. And the extractor here is the GraphQL extractor. And okay, I guess I'll quickly touch on why we chose the ETL. Import-export feature that we currently have, and that's something that I covered in the previous recording that I did for regarding import-export. If you haven't seen it, it might be useful to check it out. But the major thing is that import-export is very generic to the point where it's very hard to understand what's going on. And in order to understand anything, you need to understand everything. And with this approach, we wanted to steer away from that a little bit and provide more modularity to our changes. So for instance, if you take a look at relation factory, if you have a look at what's going on here, it's quite hard to understand. And it is a factory though, so it does try to accommodate for all types of data coming in. But we wanted to have modularity with the new approach, and being able to swap in and out modifications on demand with a bit greater visibility. But I do have to say that I will cover the NDJSON pipeline that we use, and it still uses an old approach for an important reason, which kind of contradicts to what I just said above, but or conflicts with what I said above, but there was a reason for it, and I'll talk to it in a bit. So we have an example pipeline here, and the extractor is defined for the GraphQL extractor. And there are currently 3 types of extractors that we have in bulk imports namespace. The GraphQL extractor, it just fetches the data from GraphQL API, and we use that data, we transform it, and then we create, we persist it. So a good example, actually, maybe to show not a members pipeline, although that is a good one, but also the group pipeline. So we have the very first thing that we do during group import is we create an empty group, right? In order to fill it out with information. And this is where it's happening. So we use the GraphQL extractor, meaning we fetch data from GraphQL API using this query. And this is what the query looks like. We fetch the name, the path, the description, visibility, and all these settings. Abort and failure essentially means if something fails and we couldn't create a group, abort the whole entity, mark it as failed, right? Which kind of makes sense because you don't want to import labels or import anything really if you don't have if the group creation failed, right? So yeah, some of the pipelines have this attribute which help prevent some sort of failing imports. And the next type of extractor we have is REST API extractor, which extracts the data from REST API. And one of the examples is a subgroup entities pipeline, which defines its own extractor, but under the hood, it just uses HTTP client. And essentially what it does, if when I showed an example here with bulk import, it creates an entity and then it creates trackers. And one of the trackers that it creates is a subgroups, a tracker for subgroup entities pipeline. And if I open trackers table and then search for subgroup entities pipeline, you can see that there is a tracker for it, meaning that this pipeline is going to be executed. And what it does is essentially, okay, it's checking if the group that we just processed, if it has any subgroups. If it does, we actually try to extract this data from source. We check, does this group have any subgroups? If the answer is yes, then we're gonna create more entities for it. So you can see here, bulk import entities create. So we fetch subgroups and we yield them. Then we clean up the data through these transformers, and then we create more entities for it. This allows us to preserve this structure where this group has 2 subgroups. Okay, that's how we gradually kind of fill it out with information top down, starting with root, perform all the import there, check are there any subgroups? Yes, create entities for that. Are there any projects? Yes, create project entities for that. And then, gradually we work through everything. The subgroup gets processed, we perform the same thing. Are there any subgroups in this group? Yes. Okay, create more entities. Yep. And then finally, we have NDJSON extractor, which technically uses REST API. But what it does is it downloads a file that ends on ndjson.gzip. And what it does, I guess I will show you. Let's say Apex pipeline ndjson extractor. So here we say that we include ndjson pipeline module, which sets an attribute called ndjson pipeline. And what ndjson extractor does is it downloads a file, it decompresses it, and then we read it, and then we yield it. And that's what it does. And I will touch on ndjson pipelines later on. But yeah, currently we have 3 types of extractors. I mean, technically 2. The third one is being more custom for the REST API with a bit more logic, like downloading the file, decompressing it, and then, yielding the result. For the transformers, it's pretty straightforward. I mean, we have classes that perform modifications. Those classes are quite small. Let's say prohibited attributes control transformer. Every transformer responds to a transform method. It receives context and data. It does something to the data, and then it returns the modified data. And then the load, we create an object and persist it to the database. Most of the pipelines don't even need a custom class with its own load method. Let me see, what can I, like for example here, you can just define the load method directly in the pipeline, and yeah, I guess the good thing to do is to check this pipeline module, which includes the runner module, and that's where the run method is defined. That's where we call the extractor, then we perform on the extracted data, we run all of the transformers, and then we call the load method as well. There's logic around performing the step, logging in the information. I guess one thing to note is a good place to check the logs is importer log. So for example, locally, it can be located in on GDK in log /imp importer log. That's where you'll be able to see the logs for this import. And additionally, you will be able to see bulk import failures as well. Regarding the anti-JSON pipeline, so the anti-JSON pipeline is a pipeline that uses the anti-JSON files. And if you've seen my previous recording regarding import export, we use anti-JSON files in import export as well. Let me just show you an example. Finder. Here is an example of ND-JSON. You know, if we have a look at the labels, each label represents a single JSON object, which represents a single label, right? Why do we need to use this? Why do we need to like deal with files again, right? Didn't we want to move away from files? Didn't we want to use GraphQL? And why do we need to do that now? So the reason for that is quite complex. And like initially we did want to, the idea behind this approach was to just use GraphQL. It seemed like a good idea because the input team wanted to contribute to GraphQL API and other teams expand on the API as well. And GitLab as a company is GraphQL first, which, you know, was a plus for us. But then we eventually realized that there were a few problems with it. The main reason being complexity of subrelations. If you know, there is an import-export YAML file. Or let me open the project one. You know, it's quite extensive. What we import and export is quite a lot, right? So this is what we cover in project import-export. And one of the asks for this solution was parity with import-export tool. And if we want to use GraphQL API, first of all, we don't have everything in GraphQL API to cover all of this. You know, we might have CI pipelines, we probably don't have protected tags, we probably don't have custom attributes, we probably don't have a lot of things. And we could just go ahead and extend GraphQL API, right? And we did in some cases. But what became apparent is that nested subrelation complexity is what would give us the most trouble. And what I mean by that is this. For instance, if we want to, well, let me show you. If we want to fetch a list of merge requests that includes nodes, and every node includes events, and every event includes push event payload, you can see how many layers of nesting there are. 1, 2, 3, 4. But there can be virtually unlimited number of nested subrelations, right? And that became problematic with GraphQL because there are query complexity limits on gitlab.com and just in general on GraphQL API that we ship with GitLab. It has query complexity limits that we cannot exceed. You know, the GraphQL API will just simply not return us a result. And the other problem is GraphQL API has nested pagination that would be extremely difficult to manage. And I have an example for you here. For example, if we have a project and we want to face a list of issues, and by default, the page number, the page size for GitLab is 100. You cannot exceed that. Or maybe you could. I'm not entirely sure. Maybe it's 500. Regardless, there is a limit, right? And every issue we want to also fetch nodes, and for every node we want an author and award emoji. And for every collection that is returned, there is a cursor that we have to manage, right? It's page info. Okay, the syntax is not valid, but people who worked with GraphQL before know what I mean. Like there's a before cursor, after cursor on this level. Okay, let me see. Yes, page info, end cursor, and start cursor. So there's something like that here. There's something like that here. Oops, here. And there's something like that here. Can I prettify this? No. Anyway, you get an idea that you have 3 different paginators, pagination cursors to manage, which is, first of all, quite difficult to do, but it would be slow. It would return results that you don't need. For example, I want first page of 100 issues, 5th page of notes, 7th page of award emojis, right? It's slow and maintenance hell, essentially. And on top of that, we would be producing n+1 queries. And what I mean by that, if we do not use this approach with nested pagination, then we have to fetch epics or fetch any subrelation one by one. And an example being, if let's say we have a group, or actually no, let's say we have we import 500 issues, no problem. And then for every issue, we want to fetch nodes. So that is going to essentially be issue, with ID 1, and then we want a list of nodes here, right? So for 500 issues, we do 1 request to fetch 500, to fetch all the nodes. For every node, that's at least 500 requests, right? To make things even worse, you multiply it by the amount of subrelations that you have, and that's not even considering that there can be more than 1 layer of nesting in subrelations. So you can quickly add up, and the numbers become unmanageable. Like for instance, here, in order to import 10,000 epics with 100 epics per page, you spent 100 network requests, but then if you want to also import events and labels, that's 10,000 networks requests each, in order to avoid the nested pagination problem, which is also not ideal. So we decided to have more of a hybrid approach, where some pipelines we use GraphQL, some pipelines we use REST API, and some pipelines we use NDJSON. And simply because it's much faster, and like here, 10,000 epics with events and labels is a file that is, this is complete guess, but let's say 1 megabyte, comparing to doing 20,000 network requests. Obviously, that's going to be way, way faster, both processing-wise and just the amount of time it takes to perform all these requests. And also, the import of nested data is already handled by import-export quite well. Although it does bring us back to the original point, right? The big disadvantage. Like, why did we want to have this? I mean, one of the solutions is so that the user doesn't deal with files. The other one is that we wanted modularity. But with this, we came back to the original approach, right? Which is quite hard to understand. And again, if you've seen my other overview, or if you just take a look at the import-export code base, you will realize that it's, there's a lot going on with terminology like relation factory, object builder, the tree restorer, all this good stuff. So that's currently what we are doing here and there are a number of NDJSON pipelines. For example, Epic's pipeline for groups is NDJSON. But members pipeline is not. And the rule of thumb that we kind of landed on is for simple flat relations like members, labels, milestones, you can probably use GraphQL. For more complex stuff, you should be using ND-JSON pipeline, ND-JSON approach, right? Just because it handles sub-relations so much better. And how do you know, like, which approach to use? Mostly, you just take a look at the import-export file. If the sub-relation is quite flat, you know, then you might not need it to use the ND-JSON pipeline. But if, let's say, it's something like this, right, then you definitely need to use ND-JSON pipeline. Yes, that's the ND-JSON pipeline. I guess one more thing that I wanted to show is how ND-JSON pipeline works. So when bulk import is initiated, there are two things that happen, or I guess more than two. We create pipeline trackers for every entity, and entities are created prior to this moment. But then there are two workers that are enqueued: export request worker and entity worker. So export request is a worker that just does the network request that essentially says, you know, to another instance of GitLab, hey, please export the relations. And we have export relations API, which can be viewed. It's currently available for group export, not for project, but project one is ongoing. So here it is. And what it does, it's very similar to regular export where you have a tarball, but instead of a tarball, you get small gzipped files. So here's an example of bulk import exports table. And you can view bulk import exports model here. It also has a state. And so essentially, for every group or for every project, we will have these small files, right? Instead of having one massive file, tarball with import export, you will have like right now, you see this is the import export tarball, and all of the files are in this tarball. Instead, you have smaller files like this, milestones.ndjson.gz, boards, epics, whatever, that we request the export of. So when the import starts, we go to source and we ask it, can you export all of your data? And then by the time the pipeline starts, the ND-JSON pipeline starts, we fetch that information from source if it's available. If it's not available, then we reschedule the job in the future. And that can be seen here, I believe. Right here. So this is the pipeline worker. And here we check if this is an ND-JSON pipeline. Then we check the status of the export. You know, we also check, you know, the timeout and if it failed. If it's still in progress, if it's still started, we just re-enqueue the job in the future. I think it's 1 minute. Pipeline delay 1 minute. Yeah. So ND-JSON pipeline starts. It checks, okay, this is an ND-JSON pipeline. Does the file labels.ndjson.gz exist on source? If the answer is yes, you know, continue, and then the pipeline starts. It downloads the file, it extracts the contents, and it, you know, does the modification, and then it saves the data. If it doesn't, then it re-enqueues in the future. Okay. I guess one more thing that I kind of forgot to mention, but I just realized is the pipeline's execution order matters, where we want to execute group pipeline first before for the group to be created before we import labels in it, right? For that, there is a file called groups stage, which defines the order of pipelines, meaning this pipeline, group pipeline, is stage 0. So we cannot execute any of these pipelines before we execute this one. And the way it works, I believe, import entity worker stage running. Yeah. So we re-enqueue the job. Sorry, no. We actually so when the pipeline succeeds, we ensure to enqueue this entity worker. So pipeline enqueues the entity worker, then the entity worker checks if the stage is still running, do nothing. If it isn't, enqueue jobs for the next stage. And we wait until all of the stages are complete. So you can see the list of things here. So the first thing we do is import group. After that, it's avatar, subgroups, members, etc. And then the final stage is the finisher pipeline. But the finisher pipeline is just marking. It's not really a pipeline in a way. It's just like a marking the entity is finished or failed. So you can see how we create this tree of data. We keep track of all various pieces, and then those pieces report the status of themselves. Here all the trackers perform. Some of them might fail, some of them might succeed. Then we wait for the entities to all be reported back, and then we finally update the import state as well to either finished or failed. And yeah, that's how it's performed. But we also have stage file for projects, but currently it's under development, so it doesn't have much. All of the projects that I've shown you here are empty. They don't even have repository yet. Sorry, that's a wrong group. This one. It doesn't have a repository yet. Nothing. No contents. But you can probably imagine that it's going to be repository import next. After that, all the data like labels, milestones, uploads, LFS, etc. And yeah, regarding the exports, I hope this brings clarity on how that works, and on the overall GitLab migration feature in general. Lastly, the current comparison, like I said, I mentioned before. So the group migration is covered and should have feature parity with group import export. Project migration is under development and mostly not covered. It's behind the feature flag bulk import projects, and the overall feature flag for this feature is bulk import. Yeah, I guess that's an overview. Obviously, there's a lot to take in. There's a lot of stuff going on. I haven't even shown the contents of the anti-JSON pipeline module, and I probably should have, and I will right now. But the NTJSON pipeline module defines the transform method, and it uses, like I said before, it uses import-export functionality with the relation factory, where we transform a JSON string into an object, right? If you have a label JSON object, we transform that into a label object active record model that is going to be persisted in the database. There's a lot going on here. I will not go into detail here. I think a lot of this stuff is similar to import-export overview that I did. It might make sense to have a look at that as well. But yeah, there are a lot of pieces to this, a lot to take in, but I hope this overview is, you know, can help clear some of these concepts up and help you understand this feature better. That's it. Thank you very much.